and welcome to Night Sky News with me, astrophysicist Dr Becky Smethurst. This is the monthly series where we recap everything that's been going on in space and astronomy news over the past month. But first, let's chat about what you can look out for in the night sky in the coming month. Alright, so usually we do this bit in chronological order, but I'm throwing that out of the window this month because I want to talk about something that's so exciting first, and that is Saturn and Jupiter coming within 0.1 degrees of each other on the sky on the solstice on the 21st of December. That's really close together in the sky. That's about a fifth of the width of the full moon. And this hasn't happened, that they've come this close, at least from Earth's perspective, since 1623. And it won't happen again until March 2080. So you better catch it while you can. So even as this video goes up on Thursday, the 17th of December, they will be about 0.5 degrees apart in the sky, which is about the width of a full moon. So if you can spot them tonight and then watch them getting closer and closer over the next couple of days, that would be a really nice thing to do. Plus, tonight, on Thursday, there's a toenail moon near to them as well, so you know that I'm going to be looking out for them because that's my favourite thing. Now you need to look for them in the southwest, roughly in the direction you can see the sunset just after it's gone dark. And this is true if you're in the northern or the southern hemisphere, you know, wherever you are in the world. Here's the key thing though, the closer you are to the Tropic of Capricorn, the higher they're going to be in the sky just after the sun sets, and therefore the longer the amount of time they will be in the sky before they also then set. Here in the UK, for example, they're only going to be about 10 degrees above the horizon after the sunset. So if you hold out your hand at arm's width and sort of do the little rock-on symbol, that's about 10 degrees. So you need quite a high vantage point, so a high window or a hilltop or something like that. And they're going to have set by 6 o'clock here in the UK as well. So this is something you really do have to catch while you can. Whereas if you're on the Tropic of Capricorn, like for example, Alice Springs in Australia, they'll be about 25 degrees above the horizon. So that's, you know, above roofs of houses, and it won't set until like 9 p.m. So you'll have plenty of chance to spot it. In fact, if you're in Australia, anywhere in Australia, I'm quite jealous because first of all, you'll probably have brilliant weather to actually be able to see this, but you'll also have the best view of it. But wherever you are in the world, I've put a link in the description to timeanddate.com, and that'll tell you how high Jupiter and Saturn are going to be in the sky for you, and also what time they'll set as well. So you actually have chance of seeing this, of seeing them maybe merge to looking like one object in the sky. It's being called the Christmas conjunction, obviously because of its coincidence with Christmas as well. And it's just going to be a really spectacular sight. If you have binoculars and telescopes, this is the time to break them out. Alright, so we've got a fair few of the other planets visible in the night sky through December as well, including Mars, which is very high in the sky right now, looking very bright and very reddish and very Mars-like. If you want to spot it, look towards the southeast just after sunset, so out of whatever window in your house gets the morning sun, and then you can watch it move across the night sky throughout the night, and it'll set in the east around about the wee hours of the morning. So it's in the night sky for a really nice long time at the minute, so good chances to spot it. And then if you're more of a morning person, you've got Venus again in the southeast, so looking out of whatever window in your house gets the morning sun, and that would be just before dawn. It's incredibly bright, Venus, one of the brightest things in the night sky, so it always looks particularly beautiful, especially in that early morning light. And I have to say, it would be something really nice for the family to do together, maybe on Christmas morning, if your kids maybe get you up incredibly early so that you are up before the sun is. It's a nice thing to do together. Speaking of Christmas morning, I want all of the kids out there to be very, very careful this Christmas, because I don't want you to mistake the International Space Station for Father Christmas's sleigh. It's very bright and it moves quite fast across the sky. So a lot of people will be very easily convinced that it is Santa Claus, but of course you guys will know better. So for example, in the UK on Christmas morning, the International Space Station is going to pass overhead at about 7:05 in the morning. So if you are up very early, perhaps your kids get you up before the sunrise, it could be a very good thing to look out for. Wherever you are in the world though, I'll put a link in the description below that'll let you put in your location and see if there are any passovers of the International Space Station over your area, perhaps on Christmas Eve or on Christmas Day as well. But remember, don't mistake it for Father Christmas. All right, as beautiful as the night sky is, let's move on and see what's been happening this month in space news. All right, let's start with a story that probably doesn't even deserve to be here because, let's be honest, it's not astrophysics, it's not even science. This is frankly quite bizarre story about the Galactic Federation. If you haven't heard, the ex-chief of Israel's space security program, Haim Eshed, has come out and said that a Galactic Federation of intelligent extraterrestrials has been in contact with humanity, specifically just the US and Israel, and has now started doing experiments about the nature of the universe here on Earth and in a base on Mars where there are currently both aliens and humans living there. They would not like the entirety of humanity to know about this yet because apparently humanity is not ready. Now, first off, science is about evidence-based research, and this is not an evidence-based research story, right? At all. It's just the word of one man. And as much as I would love to believe and would be quite happy to believe that there is a federation of intelligent extraterrestrials out there, and much as I would probably also believe that they don't think humanity is somehow evolved enough to join it, there's just too much politics that's part of this story to even make it believable in any way. The thing that did it for me is that this guy's got a book coming out. So my working hypothesis as a scientist is that, well, it's a marketing ploy. And so as cool and as believable as a Galactic Federation of extraterrestrials might be, until there's any evidence, let's not talk about it again. And shall we talk about some real science instead? So last week we also saw SpaceX's latest test of Starship, a reusable super heavy lift launch vehicle, aka a rocket, being developed to eventually replace their current reusable rocket, the Falcon 9, which eventually should be able to land itself in that same incredibly crazy, amazing way. So the idea is that it should be able to do both satellite launches into low Earth orbit and also human launch into low Earth orbit to places like the International Space Station, but also it should be able to do human space flight beyond the Earth-Moon system. So we're talking about Mars and maybe beyond, who knows. So they've done a couple of tests of this already. Last week's was the 8th test and the first high altitude test they'd done as well. So they sent it up to about 12,500 meters, about 41,000 feet, and brought it back down again, all in the space of about 6.5 minutes. And the way that this vehicle actually comes back down is really what's so novel and ingenuitive about this whole system. A lot of people have described it as like it's belly flopping back down. It reminds me personally of Buzz Lightyear.
This isn't flying, this is falling with style.
It then burns one of its engines to sort of rewrite itself to the vertical and essentially slows its descent so that it can land back on the launch pad, essentially, which is incredible. This whole reusable rocket technology blows my mind. It's such an amazing feat of engineering. However, the test last week didn't exactly go to plan and it ended a little bit more spectacularly than they were expecting because they couldn't reduce its velocity enough and essentially it crashed and exploded in a fiery poof ball. It was so much fun watching it live because it was so unexpected as well. And I was watching it from bed because it was 11 p.m. here, so I didn't exactly get to sleep easily after watching it just explode on the launch pad. For those of you worried about wasting taxpayer money, though, from explosions, don't worry. This is mostly actually a privately funded venture. NASA has chipped in a little bit, but the majority of it is coming from private funds. And also, it wasn't a waste either, the fact that it exploded. The test really here was the high altitude test. It was actually really the flight more than anything, and they got all the data they needed from the flight. And to be honest, they probably learned more from the failed landing than they actually did a successful landing. So this is science and engineering in real time, and it is just absolutely fascinating to watch. There was another disaster this month, unfortunately, and this one wasn't a prototype, it was an astronomical legend. This was the moment that the Arecibo telescope in Puerto Rico collapsed. Now, as an astronomer that has used data from that telescope, that clip is absolutely horrific to watch. It's like watching the opening scene of Gravity where they just destroy the Hubble Space Telescope in a matter of minutes, except it's real. It's just such a blow to the astrophysics research community and the community in Puerto Rico as well. So for some context, the Arecibo telescope is a 305 meter or 1,000 feet radio telescope in Puerto Rico. It was built back in the 60s, which ever since has been making some incredible science possible. I've used it before to measure the gas mass in galaxies. So for example, hydrogen gas actually gives out radio waves at a very specific wavelength of light at 21 centimeters that Arecibo can detect. And so I used it in my thesis to compare like how much mass is there in stars and how much mass is there in gas mass that could be used to make more stars and stuff like that. It also was the telescope that gave us the first sort of concrete evidence for neutron stars when it observed the Crab Nebula and the Crab Pulsar at the very center that was giving off radio waves with a period of 33 milliseconds. It's also been used by SETI as well, the search for extraterrestrial intelligence. You know, they're using it to search through any of the radio detections they make for signals that might have been sent by intelligent life forms. Plus, it was even used in the Bond film GoldenEye and in Contact as well with Jodie Foster, which incidentally is a film I have never seen. I've been told that is a terrible, terrible thing that I have never seen it. So I was thinking maybe I should do one of my astrophysicist reacts videos. Let me know in the comments if you'd like to see that. But anyway, there was some minor damage done to Arecibo during the 2017 hurricane season, including in the wake of Hurricane Maria as well. And then in August 2020, one of the cables from one of the towers actually holding up the detector of the telescope, essentially where all the light from that big dish is focused above it, that broke and caused huge damage to that big dish. And I talked about in my Instagram stories last month about how there was a plan in place to actually fix that damage and actually replace the cable. But before they could replace the cable, one of the other main cables this time supporting that detector above the telescope dish broke and caused even more damage. And at that point, the engineers were sent in to assess the situation, and they concluded that it just would not be safe for them to even try to fix it anymore. I think the original plan was to sort of have them abseiling out of helicopters and sort of dangling above the dish to try and fix it. And it was at that point that the NSF back in November, the National Science Foundation, who manages Arecibo telescope, decided to decommission the telescope. And ever since then, they've obviously been monitoring it very closely. They've been noticing that smaller cables, like a couple of them, have been breaking each day. So they knew that it was close to collapse. So they put in sort of a safe zone around it, made sure that there was no one in the area so no one could be hurt when it did collapse. And so when it did, I mean, well, they were ready. So they even managed to get drone footage when it very sadly finally came crashing down. All right, shall we have some happier astrophysics news now?
Can we get back to politics? Please.
This month saw the huge data release from the European Space Agency's, or ESA's, GAIA mission, which is essentially attempting to map the positions, the distances, and the motions of over 1 billion objects in our night sky. And so the majority of those are stars in the Milky Way, but also you've got some comets and some asteroids in the solar system, and also some planets as well that GAIA is monitoring, but also some extragalactic quasars as well, you know, because you've got to keep us supermassive black hole fans happy, you know? So the idea is to essentially create an incredibly precise map of the positions of billions of stars in the Milky Way. But if you also measure their velocities, then you get their motions as well. And with their motions, we get a glimpse into how the Milky Way as a whole and the star and planet systems within it have evolved to their current state, but also what might happen in the future. So there's been lots of really cool science that's come out of the previous 2 GAIA data releases as well, including the GAIA sausage, which I talked about with Brady over on his channel Deep Sky Videos. Then there was also the Antilla 2 galaxy that was discovered back in 2018. And that was like a little companion galaxy to the Milky Way of about 10,000 stars. And it was the faintest galaxy that had ever been discovered. And then, of course, we had the Radcliffe wave came from GAIA data as well. This was this like sine wave of gas that was running through one of the spiral arms near the sun, which I talked about in a video back in January 2020, you know, back in simpler times. And the data dump from GAIA this time as well, this 3rd data release, has also not disappointed. Here is its latest map of the sky, which shows the position of over 1.8 billion sources, an increase of about 100 million on the previous data release. And this release also has color information on the stars too. So you can see how there's a lot of color in this map. The color tells you about the star that you are actually observing, but it also has more info on the movements of stars at the very edge of our galaxy too. And one of the first big pieces of science has obviously been done by the GAIA collaboration. You know, they get first access to the data. So one of the results that came out of this was led by Kleiner. And what they did was they measured the speed of the solar system with respect to the rest frame of the universe. So it's really difficult to measure the speed that the sun is going around the Milky Way when obviously everything else around us is also moving as well and is also orbiting the center of the Milky Way. There's nothing stationary to measure your speed with respect to. But do you remember those extragalactic quasars that I was talking about before? Well, with those, you can sort of triangulate your position. You can sort of triangulate the speed that you're moving with respect to those, as long as you also know their positions and their motions incredibly accurately, which you also get from GAIA. It's like they did this on purpose and they thought about this beforehand. And what they found is that the sun, or the solar system as it orbits the center of our galaxy, speeds up, it accelerates by about 0.2 nanometers per second squared, which means that every second it speeds up by another 0.2 nanometers a second. And what that means is essentially as the sun it moves on its trajectory, it gets deflected by about the width of an atom every second, which doesn't sound like much, but over a year that actually adds up to about 115 kilometers. And so what they've been able to isolate here is not just the fact that the sun is moving and moving in some direction, but actually been able to isolate the fact that it is curving. It's actually on an orbit, roughly circular, around the center of the Milky Way. And I really liked how this result tied in very nicely with another result that came out this month. This one from the Japanese VLBI radio astronomy telescope, VIRA. It's one of these huge arrays of antenna that give you super detailed resolution because you essentially make like a 2,000 kilometer wide telescope. So they were also trying to get very precise positions of objects in the sky, but unlike GAIA, which did it for like 1.8 billion stars, these have done it for 99 masers. And if you're just thinking, Becky, you malfunctioned, did you mean to say laser? I didn't, I meant to say maser. It's just a very specific type of laser. So like laser is an acronym which stands for light amplification by stimulated emission of radiation. Maser stands for microwave amplification by stimulated emission of radiation. So it's just a very specific type of laser that's in the microwave regime of the electromagnetic spectrum. So essentially what a maser is, it's a clump of gas that contains probably like water or methanol or formaldehyde or something like that. And what you do is you can sort of shine radiation on it, perhaps like UV light or X-rays or something like that, and it can be encouraged or stimulated to emit microwaves. And when it does that, it's an incredibly, incredibly bright emission line in the microwave. So it's nice and easy to be able to observe, and it means that because it's so bright, you can get very precise positions from it using these big radio antenna. And they're very common in the sort of gas around like a supermassive black hole, so what we call the accretion disk, where the gas is spiraling around it, but also you find them dotted along the Milky Way's spiral arms as well. So they're a really good way to sort of map out the positions of things and also work out, you know, distances to things as well, in terms of like how far is the sun away from the supermassive black hole in the center of the Milky Way. And so that's exactly what they've done here. They've essentially been able to find the position of the sun and the Milky Way with respect to the very center of the galaxy and the supermassive black hole there to, you know, the most accuracy and precision that we've ever been able to do it before, which means we've obviously revised our estimate for how far are we away from the center of the galaxy. And essentially it's put us about 2,000 light years closer than we thought, which means that because we're closer in, we're orbiting a little bit faster than we thought as well, by about 7 kilometers a second. Now, I've seen a lot of headlines that's like, the sun has moved closer to the black hole. The sun has not moved, right? The sun is in the same place as it was before. We've just revised our measurement of where it is. It's like, did you see the news this month about how they'd revised the estimate for how tall Everest was? They basically added about 86 centimeters to the height. Everest did not grow 86 centimeters overnight, right? It was just that our measurement of it changed. And it's the same thing here. And you don't need to worry either about the fact that, you know, we are orbiting a supermassive black hole, because that's fine. We're orbiting it. We're in a very stable orbit. We're too far away to, you know, get sucked into a black hole. It doesn't mean we're going to fall into the black hole at the center of the Milky Way. The same way that Earth is happily orbiting the sun, right? It is not spiraling into the sun. It is not falling into the sun either. It's not going to end up in the sun, right? It's happily orbiting it. And in the same way, the sun and the solar system are happily orbiting the center of the Milky Way, where there just happens to be a supermassive black hole. And one of the things that I'm hoping for 2021 is an image of that supermassive black hole at the center of the Milky Way, just like we got for M87 last year. I have got my fingers crossed that that is on the cards for 2021. All right, that's it from me this week and for this year as well. I'll be back in January with more fun space videos, but until then, I'm going to be having a nice rest over the Christmas break. If you celebrate Christmas, Merry Christmas. Please stay safe out there whilst you're having fun and do everything you can to protect your family. On a happier note, Happy New Year, everyone, too. I'm going to say it now. Here's to 2021 and hopefully all of the really exciting space news that's to come. This video is sponsored by Brilliant. Brilliant is a problem-solving website with a huge range of courses across all areas of science and maths that are really interactive and fun as well. They essentially teach you by getting you to think logically like a scientist. So if you want to know more about the methods the GAIA mission is using to, for example, get distances to stars in the Milky Way, then check out this module on parallax as part of their astronomy course. Or if you want to know why GAIA is bothering to record the colours of stars, check out this module on the HR diagram, the Hertzsprung-Russell diagram, and you'll learn all about how and why colour is related to star size. If that sounds like something you'd be up for, then head over to brilliant.org/Dr Becky, that's DRBECKY, and sign up completely for free. Plus, the first 200 people that go to that link will get 20% off an annual premium subscription. So I've put the link in the description below. If you click on it, it essentially lets them know that I sent you. So head over there and treat yourself to some new knowledge. All right, so usually I do this bit in chronological order. Chronological? And the idea is that it should be able to do, but, oh, hello, little jingle bell. Little jingle there for you. 41,000 feet, and then brought it back down to, and they got all the data they needed from that tester's bloody motorbike. Do you mind? Where could you possibly be going? Keep an eye on the sky to see if there are any extraterrestrials trying to communicate instead of light, amplifying, whatever laser stands for. It stands for... What does maser stand for? It definitely stands for microwave, I think. But what does laser stand for?